Bismillahirrahmanirrahim. My dear students, Assalamu alaikum. You are watching Math with Yasir Arafat. We have a lecture 1 on exercise 4.4 and we have to discuss three very most important question, most expected question of the derivative of exercise 4.4. So here we are going to discuss how to find out the derivative dy upon dx of parametric equation. So what are the parametric equation? If x is the function of theta and y is the function of theta, that means x and y are equal to the third variable. So those type of equations are called parametric equation. So if it is fx is equals to f of theta and y is equals to f of theta, these equations are called parametric equation. Things like that here, this is x is equal to a times theta minus sine theta and y is equals to a times 1 minus cos theta. So here x and y are equal to f of theta. So these two equations are called parametric equation. And here we have to find out the derivative of these two parametric equations. So we have to discuss step by step of this question how to find out the derivative of parametric equations here. So this is differentiate with respect to theta. So just we have to apply the operator d over d theta. This is x, d over d theta, a theta minus sine theta. So the derivative of x will be dx over d theta. And here we have to separate a because its coefficient in the form of constant. Now here the derivative of theta, it is equals to 1 minus the derivative of sine theta, it is equals to cos theta. So here a is the coefficient in the form of constant, therefore we have to separate this one here. So here the derivative of theta, it is equals to 1 and the derivative of sine theta, we have the formula, the derivative of sine theta, it is cos theta. This is the derivative of dx upon d theta of this function, this equation. Now take out the another equation here, that is a times 1 minus cos theta. So here again we have to find out derivative, differentiate with respect to theta. So just apply the operator here, that is d over d theta, a times 1 minus cos theta. So the derivative of y will be dy over d theta. It is a, it is the coefficient in the form of constant, so we have to separate this one. Now derivative of 1 is 0 minus derivative of cos theta, it is minus sine theta. This is the derivative of cos theta. We have the formula, the derivative of cos theta, it is minus sine theta. So this is dy over d theta minus minus plus a sine theta. So this is the derivative of dy upon d theta. But here we have to find out dy over dx. We have to find out dy over dx, that can be written in this form, dy over dx, dy over d theta whole divided by dx over d theta. Indirectly we can write down this because this d theta will cancel out, we will get dy upon dx. That means indirectly dy upon dx can be written in this form. So here dy over dx. So the value of dy over d theta, it is a sine theta. And the value of dx over d theta, it is a times this one, 1 minus cos theta. So this will cancel out to this one. So dy over d theta, it is equals to sine theta, it is equals to sine theta 1 minus cos theta. So here we have to, this is the dy over dx derivative of these parametric equation here. But here theta, it is given to you pi over 2, that is 90 degree. So just we have to put the value here, that is x is equals to this is theta equals to pi over 2. So this is theta, it is equals to pi over 2, that is sine pi over 2 divided by 1 minus cos pi over 2. So this is dy over dx, theta, it is equals to, pi means 180, 180 upon 2 means 90. So sine 90, the value of sine 90 is 1, and the value of cos 90 is 0. Cos 90 is 0. So therefore, this is 1 over 1 means 1. So the value of dy over dx, that is theta equals to pi upon 2, it is equals to 1. So this is the derivative of parametric equation when theta, it is equals to pi upon 2. Now the same exercise, the next important question of the same exercise. Again the parametric equations are given, which we have already explained in the first question. Now this is x is equals to ln of t plus sine t. So here differentiate with respect to t. So this is dx over dt. We have to apply the operator d over dt on both sides. This is dx over dt, it is equals to, now we have to find out the derivative of ln t and then the derivative of sine t. So the derivative of ln t, it is equals to 1 upon t, because we have already discussed in the last question the derivative of ln x, it is equals to 1 over x. This is the formula of ln x. So here it is ln t, so its derivative will be 1 over t. Now here this is the sine t, the derivative of sine t, it is cos t. So this is the derivative of dx upon dt of this equation. Now take out the another equation here, that is y is equals to e of t plus cos t, differentiate with respect to t. Apply the operator d over dt on both sides. So this is e of t plus cos of t. So this is here the derivative of y, it is dy over dt. Here the derivative of e of t, it is remains same because we have the formula of exponential function e of x, it is remains same. So here derivative of cos t, it is minus sin t. Derivative of sin t, it is equals to cos t, and the derivative of cos t, it is equals to minus sin t. So this is dy over dt, it is e of t plus minus minus sin t. Here we have to find out dy upon dx from the parametric equation. We have explained what are the parametric equation in the previous question. So this is dy over dt divided by dx over dt, can be written dy upon dx like this. So just we have to put their values here. Dy over dx, it is equals to dy over dt, this is the value of dy over dt, it is e of t minus sine of t, divided by dx over dt, this is the value of dx over dt. So this is the answer of these parametric equation dy over dx of these parametric equations. Exercise 4.4, question number 5. Now again we have a third question here of the same exercise. We are going to discuss three important questions of exercise 4.4. So here this is again the parametric equations are given and we have to find out dy upon dx. We have to find out dy upon dx here. So this is x is equals to sine t cube. This is cube, it is on the angle here. So here differentiate with respect to t. So this is dx over dt. So we have to apply the operator d over dt on both sides. Like this. Just we have to apply the operator here. So the derivative of x, it is dx over dt, that is equals to, now here we have to separate this one first, sine t cube plus d over dt cos t cube. So this is dx over dt. So the derivative of sine t cube, it is cos t cube. And then we have to find out the derivative of its angle because its angle is t cube. So first we have to find out the derivative of the function. The function is sine. The derivative of sine is cos with the given angle. And then we have to find out the derivative of angle there. Now here, come to this one. The derivative of cos is minus sine with the same angle. The derivative of cos is minus sine with the given angle, and then we have to find out the derivative of its angle, and the angle is t cube. So this is dx over dt, that is equals to cos t cube, and the derivative of t cube is 3t square. Coefficient will multiply with the power and decreases 1 from the power. So 3 ones are 3, 3 minus 1 is 2. So here this is plus minus minus sine t cube. Again, the integration of t, derivative of t cube is 3t square. So this is the dx over dt, that is equals to, take out 3t square common. So this is cos t cube minus sine t cube. This is the derivative of dx upon dt of the first equation here. Now we have to take out the second equation, that is y is equals to sine t plus 2 cos inverse t. So just we have to take out the differentiation with respect to t. So this is dy over dt. Apply the operator on both sides. Dt, because we are going to find out the derivative with respect to t, that is why we have to use the d over dt. So this is again here d over dt 2 times cos inverse of t. So this is here dy over dt. So the derivative of sine t, it is cos t, 2 is its coefficient, remains same, and the derivative of cos inverse t, it is minus over 1 minus t square in the radical. We have to use the formula cos inverse t, its derivative is minus 1 over in the radical 1 minus t square. So this is the derivative of second equation here. We have to find out dy over dx, that can be written in this form, dy over dt whole divided by dx over dt. So this is dy over dx. So this is the value of dy over dt. So just we have to put its value here. This is cos of t minus plus minus 2 over 1 minus t square and whole divided by 3t square times cos t cube minus sine t cube. So this is the answer of this question here. Dear students, we have discussed 3 most important question of exercise 4.4. That was the third question. If you like this video, please share it and subscribe my channel Math with Yasir Arafat. Thank you so much. Allah Hafiz.